Welcome to my mathematics class. In this class, we would like to look at a topic in Form 2. And the topic is angle properties of a circle. We want to start with, we want to go straight to the first theorem concerning angles subtended by the same chord or the same arc in the same part of the circumference. So we need to draw a circle, and if you are with me, you need to draw a circle, let's say radius 5 centimeter, and then using the same radius, like in this case I have used this particular radius, this one, and with the same radius I have made these marks here on the circle. When you do that, you will have constructed an angle of 60 degrees at the center of this circle. We want to see what happens when we make this chord. This arc is an arc from here to here. We are going to label these 2 points. We will label them. We have this one as point A and this one as point B. You see, now in this case, the line joining A to B is called a chord. We can actually join AB so that we see what you're talking about. We can join AB like that. There you have it. We have joined A to B. And now what we have is the chord AB. So we say the chord AB subtends an angle. See? We can have an angle subtended by this chord on the circumference, like this. We make the chord to subtend an angle on the circumference of this circle. We can do the same here. You see that? So the angle that we have on the circumference of this circle, we say is subtended by the chord AB. Not a very straight line there, but I think we can see that the angle here, as the angle we are saying, is subtended by the chord AB. We can call this angle X. So the question now we want to answer is what is the relationship between this angle and any other subtended by the same chord on the same part of the circumference. Now, when we say the same part of the circumference, you see that the chord AB divides the circle into 2 parts. There is the upper part, where you go this way, up to B. We call that the major arc. So there is the angle subtended in the major arc on that part of the circumference. The same chord can subtend an angle on the other side of the chord, like that. So we have this angle here, this obtuse angle down here. Now we say that this angle, this one, and even this one, are subtended by this chord. But this one is on the major arc, and the other one on the minor arc. So I would like you to do the same in your book. Construct a circle, mark those 2 points, maybe the same radius, like that, and make that chord to subtend the angle of the circumference. Then measure that angle. If you have used the radius like I did, you will get 30 degrees. Confirm what the angle subtended on the same part of the circumference, yeah, by the same chord will be. That one. Find out what this angle will be. And do the same with other angles. You can subtend more. There. You can call this one Y. You can call this one Z. We can also make the same chord to subtend angles on this side. And that's why we said on the same part of the circumference. These others are on the other part of the circumference. If you are accurate, if you have drawn your circle accurately and you measure the angles accurately, you should find that angles subtended by the same chord on the same part of the circumference are equal. In other words, you should find that x is equal to y is equal to z equal to 30 degrees for this particular one. You could also try the same with several other angles. So our first theorem concerning circle geometry, the angle subtended, the angle properties of a circle is that angles subtended by the same chord on the same part of the circumference are equal. If you also measure these ones, those that are subtended on the other side of the chord, you will also discover that although they are obtuse, they will also be equal. So the theorem is angles subtended by the same chord on the same part of the circumference are equal. Now we would like to use that to work out a question here. There is a chord. I'm going to do it freehand so that we save on time. There is a chord PQ. Okay, we have a chord PQ, and we are given that the chord subtends an angle of 20 degrees, and you are required to find this, that, yeah. Okay, we want to find the angle X, Y, and this is W, and we want to find this other angle here, that is T. From our theorem, all those angles are equal. X is equal to Y, W is equal to T, which is equal to 20 degrees. Now, for your homework, find out if this is W and this is T. Find out if this angle is 150, what will this one be? Find M. Okay, so we are going to stop there for now. In the next lesson, we are going to see the relationship between the angle subtended at the center. Now we can make the chord to subtend an angle at the center, not necessarily on the circumference. And we are going to find out what relationship is there between the angle at the circumference and the angle at the center. Remember to subscribe so that we move on together. Otherwise, from me now, it's goodbye.